Hi everyone, I am Shadab Imam and today we are going to discuss about operations research. तो काफ़ी स्टूडेंट्स को जो नेटवर्क एनालिसिस है उसमें काफ़ी परेशानी होती है, काफ़ी दिक्कत होती है. तो आज हम उस पर बात करेंगे, उस पर डिस्कशन करेंगे एंड वी विल ट्राई टू फाइंड आउट व्हाट आर द लूप होल्स दैट जनरली occurs when students solve. So let us start and let us begin with the word project management. Now, when we are talking about project management, it means managing the activities which compile a project. So basically, there are number of ways to do project management. But what we are trying to learn right now is about network analysis. So this is the thing we are going to focus on. And in network analysis also, there are various ways to do network analysis. So we primarily focus on the two main methods that we are going to do in this series. So one is the critical path method, CPM, and the other one is PERT, which is project evaluation and review technique. Now as we can see, first we need to understand what project is. So project basically is the interrelation of activities to complete or to achieve any physical or defined target or a goal. Okay, so basically it is as written that it is a combination of interrelated activities which must be executed in a certain order before the entire task is completed. So that basically is project, and I think we all know about different types of projects, basically construction projects which we usually see around us. All right, now basic requirement of a project. Why do we work on a project? So it has some basic requirements why we work on a project. So let us see that. So it should be completed without any delay. So that is one more factor. It should be completed within the limited time. Then it should be available. It should use available manpower and resources as small as possible. So we always want to consume very less resources and very less manpower to achieve whatever we are doing in a project. And finally, it should involve as small as investment as possible. That means we always try to minimize the investment that we do on a project. So these are the basic requirement of a project which we try to achieve. All right, now let's move a little ahead and understand what are the terminologies that we are going to come across when we are dealing with network analysis. So these things may look difficult when we start, or may look difficult when you do it by yourself, but trust me, it is going to be a very simple as we are going through. Okay, so let us understand some of the terminologies. So first terminology is the activity. So it is basically a physically identifiable part of the project. That means whatever thing we do with resources, with time, with money, and they are called as activity. And suppose I is any instant of time where we are starting something. Let us understand it as a project. So if our project is to build a house, at some point of time we are going to start our first activity. Okay, so let us take that time as I. Now I'm going to represent one activity which is laying foundation. Let us name that activity X. So now the first activity I'm doing is laying out the foundation when we are building a house. So it is represented by activity X and it is represented by an arrow. And Dij, when I have written here, it represents the time consumed by the activity. That means how much time it will take to lay down the foundation perfectly. All right, and then we have another instant of time J at which our activity is completed. So when we start an activity, we name it as I. At I instant of time we started, and after completing the activity we move to J instant of time. The time is J. So time duration of an activity is written as Dij. Okay, here. Now let us understand some more terminologies. Next is event. Event is basically the instances of time or points. Here we can see when we have written instant I, that is at a particular time I, the activity is started. So it is called the starting event, and a particular instance of time j, at that instant the activity is completed. So these are called events or nodes. Now, as we have talked about activity, we know that activity are physical activities. They consume money, they consume time. But event is the instance of time, so it does not consume any more time. Okay, so we need to keep things in mind, and they are represented by circle. So this is event I, event j, or we can call it node I or node j. Next is the path. Path is the unbroken chain of activities. Suppose if I take some network like this is some project network, and what all things I can see is, I can see number of different paths here. So let us see what path I can see here. So basically I can see path consist of 1, 2, 4 and 5. So as I move from 1, 2, 4 and 5, this constitute one path. All right. Or I can represent it in the form of activity. So this path 1, 2, 4 and 5, this constitute of 3 activities, which is activity A, C and E. So it can be written as activity A, C and E. Now similarly, there can be another path in this network, which is 1, 3, 4 and 5. So this is 1, 3, 4 and 5. Or it can also be represented by activity. So this constitutes activity B, D and E. So this is activity B, D and E. So when we are going to go through, we are going to see different representations. It can be in the form of this 1, 2, 3, 4, 5. Okay, or it can be in the form of A, B, C, D, E activities. So both are correct, both are absolutely fine. You can go either one of them. Now let's see the next one, which is network. So network is basically a graphical representation of how activities are interconnected, and this whole diagram, as you can see, this whole diagram represents a network of a project, where we can realize that some of the activities, suppose we take activity C. Activity C is dependent on activity A. Dependent means it can only start when activity A is completed. So all these little things we need to keep in our mind whenever we see such network diagrams. Okay, these all small informations will compile and give us a breakthrough when we are going to solve and create the network. Let us see how. Now let us understand the objective of CPM PERT. So objective of CPM PERT is to provide analytic means for scheduling the activities. That means when we are scheduling the activities of a project, we want them to be in a proper sequence, which will give us lesser cost, which will give us lesser use of resources and manpower. So that's why we do CPM and PERT analysis. Now let us understand the techniques, and we have certain steps to understand that techniques. So this is the chart, as you can see. This is the basic chart we have to understand this. And before moving up to the chart, let us understand the steps here we have. So first one is to define the activity of a problem, their precedence relationship and their time required. So first thing we do is identify what are the activities that are going to get our task completed or get our project completed, and then we will see the precedence. Precedence means which activity is to be followed by which activity. There suppose when we say about construction of a house, there are some activities which can only be start when the other activity is completed. Say suppose I want to put up a walls around the houses, so that can only be done after we have a proper foundation. Okay, so these are the activities, they are dependent. So I can only raise a wall after I have the completion of foundation activity. So that is what means precedence. So we need to find out the exact correct precedence and then the time required by each activity. So these all things we need to do first. And as we move ahead, we need to see the precedence relationship among the activities represented by the network. Now, once we find out the precedence, we need to create a network diagram which looks something like this, where we can see that in this network diagram, C is preceded by A, activity D is preceded by B, and activity E is preceded by both C and D. That means activity E cannot be started unless C and D both are completed. So these are the dependencies we need to keep in mind, okay, whenever we are moving ahead. Now let us understand the next step, which is computation to develop a specific or computation to develop the schedule of the project. So we need to identify what is our main task, either to minimize the time of the project or to minimize the cost of the project. According to these, we will do calculations, and these calculations are a part of CPM and PERT. In CPM we do different level of calculation, in PERT we do different level of calculations, so that we will see ahead when we move. And after that, finally, the schedule must be revised to reflect the realities on the ground. So once we are done with our calculation, with our network model, we will try to implement it, and it is very, very important to reflect on what we have done on the real ground, because as we see on the real ground, there may be different factors that affect our project time. So as and when required, we need to come back again. Okay, we need to come back again here and again change our network scenario. So whenever this is required, we need to do it, and we tend to do it every time we want our project to get completed on the minimum time or minimum cost basis. Now let us move ahead again and let us go to the main part, how to draw the network diagram. Now before moving ahead, I want to tell you that apart from this YouTube live session, we have created the entire course on operations research, which is available on the application we have. You can click and see the application and the content in the link given in the description. And now let us start how to draw network diagram. This is the most difficult part for the students, because they might know the calculation that CPM and PERT has, but the biggest challenge is to draw the network correctly. Okay, so what we'll try to do is we'll try to get some rules, and on the basis of those rules we will try to draw the network correctly, and we will see number of examples how to draw a network. So let's move ahead, and there are some rules for network construction. Let us read those rules first, and then we'll come back and see how it has done. So first thing is that no two activities should have the same starting and ending event. Okay, this is very, very straightforward thing. It is saying that if there is event 1, then no two activities, activity A, let us name A, and B. So no two activities can have the same starting and same finishing events. Okay, so they cannot start from start from event 1 and end on event 2 together. Okay, one has to be different. So this is the first rule that we are going to follow. Now apart from this, the activities are put in logical sequence based on the precedence. Now the precedence is, we have already discussed what is precedence. So according to the precedence, we will draw the network. Suppose if activities C is dependent on activity A only, so we need to start activity C once activity A is completed. That's what we have discussed, and we will see variations in it as we move ahead. Now the third rule is, if needed, use dummy activity to show logical relationship. Now this is one big word that we need to remember, dummy activity. Now what is this dummy activity? We have talked about that activity is physical, which consumes energy, which consumes money, which consumes time. But when we are talking about dummy activity, they aren't a real activity. They are created by us. They are created by us just to show the precedence. All right. How dummy activity works, we will see in a moment when we draw the network. All right. So just keep this in mind, that dummy activity does not consume any power, does not consume any money, because it is created by us. And we use dummy activity whenever there is a problem in precedence. So let's move ahead and see the next rule. Each activity is represented once and only once in a network diagram. So we cannot represent any activity twice. That's very simple rule. And there is only one starting and ending event in the network. All right. So there can be only one starting event or starting node, and there can be only one ending event or end node. Now this is one of the very important rule that I want you all to remember. Most of the students just forget this last rule, and because of that they draw multiple nodes of starting and finishing, and that's where the problem arises. So please remember this last rule. It is extremely important. Now let us see this diagram. I hope you can see this. Draw the network diagram for the following activities. So these are the activities and these are the precedence. So this shows that activity A here is preceded by none. That means it can start immediately. We don't need to wait for any activity to get completed. So when there is no precedence, that means you can start that activity immediately. So A and B has no precedence. That means A and B can be started immediately. Now activity C depends on A. That means C can be started when only activity A is completed. Activity D depends on A and B. So activity D can be started when A and B, both the activities are completed. So this is the precedence. Now let us start. So let us start with the starting node. We know that there will be only one single starting node for a network. So let this be one starting node. Now, as we can see, there is no precedence for activity A and B. That means we can start activity A and B together. So let us start them from the same single starting node. Now, as we move ahead, we can see that activity C depends on only activity A. All right. And we need to see whether A is in combination with any other activity or not. So yes, we can see that here activity A is in combination with activity B. So what we have to do is, first thing, we'll end the activity A here. Now you must have observed one thing. Before moving ahead, let me discuss this point because this is very important. When I have drawn activity A and activity B, I have not drawn the end event. All right, both the arrows are open and I have not drawn the end event. This is the biggest mistake that students do. As soon as they draw the activity, they draw the end event. Never ever do that. Okay, if you do that, you'll fall in a trap. Okay, let us start. So as we see, activity C depends on only activity A. Now we can realize that we can end activity A because we need to start activity C. So here we have ended activity A, and from here I started activity C. Okay, that's fine. Now as we want to move to activity D, we realize that it depends on A and B both. So where should I start it from? If I take this arrow on this node, it will not be possible because we have already seen in the rules that no two activities can start from the same starting and ending event. And we have also seen that if I start activity D from here, from this node where A is completed, then there is no dependency about B. There is nothing we are seeing about B. So in these manners, whenever we have A here and A in combination with any other, that shows that we need to use a dummy activity. Let us see how we are going to use. Because we want dependency from A and B, and we have B here. So let us draw a dummy from A to B. Now this dummy activity does not consume any time. It only shows the dependency. That means at this node, activity B is finished here, and activity A via dummy, I'm showing the dependency of activity A via dummy. So at this node, I can say that activity A via dummy and activity B both are completed. Now, as we can say both are completed, we can start activity D from here. All right. Now there are no more activities to be drawn. Now, once we have completed the activities, what we will do is we will draw the end event. End event means no matter how many arrows are open, we converge all the arrows to a single node. So we right now have two arrows of activity C and activity D. So we will converge them to a single node, and this will be the finishing node. So here it is, very simple. Our network is ready. But there is one more thing to do. We need to number these events. So how do we number these events? Let us see that also. Okay, there is a proper rule for numbering the events, and that rule is called as Fulkerson rule. All right. So let us see the Fulkerson rule first, and then we will apply it on our network. So rule number one is the initial event which has all the outgoing arrows with no incoming arrows is numbered 1. All right. Then delete all the arrows coming out from node 1. This will convert more nodes into initial events. Number these and 2, 3 and so on. And then finally delete all the arrows out going from these numbered event to create more initial event and assign the next numbers to see these events. So these are three very basic simple rules. Let us understand how these work. It is saying that basically when the starting node is there, when there is no finishing activity, this is called as initial node here. So we have one initial node. Let us number it 1. Okay, sorry, let us number it 1. All right. Now, as we move ahead, okay, what we need to do is we need to assume that all the outgoing arrows from this one numbered node is deleted. Now we don't have these two arrows. So what happens after this? After this, we have one more initial event, which is this. This is not initial event, remember, because the incoming arrow is here. Okay, so this is not initial event. Only this one is initial event. So we will name this as number 2. Now, as we move ahead, we will delete all the outgoing arrows from node 2. So activity C, and this dummy activity is deleted. Now, once this is deleted, we have another initial event, which is this, and let us number this as node 3. And finally, we have one node left. This is our final node 4. So here our diagram is completed successfully, and we have numbered the event also. Now let us understand few more examples. Okay, because one example will not be enough for you to understand completely. Let us understand some more example. So here is one of the very good examples we have. You can see the activities. There are a number of activities we need to go through, and there is a certain set of precedence we need to follow. So let us start. We will start with the initial event. This, can you see this? This is the initial event. Okay, now let us see the unpreceded activity. So A and B here are unpreceded. That means undoubtedly we can start two activities from there, which are activity A and activity B. I hope this is clear. Okay, fine. Now let us move to activity C. As we can see, C depends only on A. All right. Now what I will do very wisely is I will see in the precedence column, okay, throughout whether A is being used in combination with any other node or not. So here A is alone here. Here also A is alone, and I did not find any other A. That means A is not being used with any other node. So this makes my work extremely easy. So what I'll do is, now I'll end the activity A and start activity C where activity A ends. So let us start activity C and let's move down to activity D. Now when we see the activity D, it depends on B. Again we will see that in the precedence column B is combined with any other activity or not. So B is alone here. Again B is alone and there is no B here. That means B is also alone only, and it does not it is does not used in combination with any other node. So let us end the event B. Let us end the event B and start event D. All right. As we move to E, it depends on A. We have already seen that we don't have A in combination, so we can start E right from this node where A is ended. Clear? Please remember this. At this node A is completed and C is started. So it does not matter how many activities start from an event. It does not affect it. The only thing is that matters is how many activities are completed at that event. So at this event, activity A is completed. Let us move to activity F. F depends on B only. So again, after this node where B is completed, we'll start with activity F. Okay. Now again, I want you to see that I have kept all the arrows open. This is the basic thing you need to do. All right. Now let us move to activity G. G depends on C and D both. Now let us see that if C and D are used with any other node or they are used individually in the precedence. So I can see that there is no C or D in the precedence. So what I'll do is I'll simply converge them C and D to a common node, and I can start now activity G from here. Very good. Now let us move to activity H, and it depends on G and F. And as I see there is no G and F further in this precedence, so I'll convert G and F activity to a single node and I can start activity H. Very nice and easy. Let's move ahead. Activity I depends on activity E. So we need to see whether any E's are there further. No more E in the precedence. So we can end activity E here and we can start activity I. Fine. Then activity J depends on H and I. So I can converge H and I to a single node and I can start activity activity J. And then K depends on J. So I'll end activity J and start activity K. Now, as all the activities are finished, I will see how many open activities are there and converge them to a single node. So as we see that only activity K is open. So let us close it or converge it to a single node. So this is our network diagram ready. Now as our network diagram is ready, let us now quickly do the numbering part. So as we have done the initial event, which is the first event where there are only outgoing arrows and no incoming arrows. So we will name it as 1. This is 1. Now we will erase all the outgoing arrows from 1. So now we have 2 initial events, this and this. Let us name them 2 and 3. Again, we will delete all the arrows from 2 first. Let us delete the arrows from 2 first. So I'll get this as 4. And this here I have 1 incoming arrow. Now let us delete the outgoing arrows from node 3. So D and F are deleted. That means I have another initial event, which is this. Let us number it 5. Now let's delete all the outgoing arrows from this. So I have deleted G and F also. Now this is the initial event. This will be number 6. Similarly, this will be 7, 8 and 9. Extremely easy and comfortable when we do with it. All right. Now let us see one more example, one more variation in this network drawing, and I hope after this you'll get to draw any network diagram you want. Okay, so let's move ahead very quickly. Now this is our question. This time you can see that the precedence here given in this form, which includes greater than equal to sign or something like this. All right, so first of all, after this we need to make a precedence column. How we are going to make, let us see. So we have this much activities, A, B, C, D, E, F, G up to K. Clear? Now what we see and read here is that activity A, C and D can start immediately. That means there is no precedence. So let us put a dash in front of A, C and D. Here it is, A, C and D. They are unpreceded activities. Fine. Now as we see here, E is greater than B and C. This shows that activity E depends on B and C. All right, so activity E depends on B and C. This is what it means. So let us write in front of activity E, let us write B and C. Fine. Similarly, F and G depends on activity D. Okay, so now here the statement is a little different. It says activity F and activity G are dependent on activity D. That means F activity depends on D and G also depends on D. So what we'll do, we'll go to activity F, we'll put D, we'll go to activity G, we'll put D. So this is how we should prepare the precedence matrix, and I think this will be easy from now here on. So activity H and I depends on E and F. That means activity H and activity I both depends on EF. So let us write it here. Okay, fine. Similarly, J depends on I and G. So J depends on activity I and G. K depends on activity H. So K depends on activity H. And then activity B depends on A. So here it is, B depends on activity A. So again, this was not as difficult as it looks. I think we have done very well till now. So let us move ahead. Let us create the unpreceded activities first. So let us draw the starting node, and unpreceded activities are A, C and D. Let us quickly draw A, C and D. Fine. Very nicely. Now let us move to activity B. It depends on A only. Okay. And let us see in the precedence if A is in combination with any other. No. So immediately I can end activity A here and I can start activity B from here. Okay. So let us again move ahead. Activity E, because C and D we have already drawn. Activity E depends on B and C. So let us see if B or C appears individually or in combination with any other. So we can see that there is no B and C ahead. That means we can terminate them at the common node here. So B and C are terminated here, and here we can start activity E. Now let's move to activity F. F depends on only activity D. So now let us see again in the precedence, D appears individually again. So we don't have any problem with D appearing again alone. We only have a problem when activity D appears with any other precedence activity, any other precedence node. So let us see here. So there is no combination of D. So we can rightly end D here and start activity F. Similarly, activity G also depends on D. So after D is completed here, we can start activity G also. Again, you will see that every time I draw the activity, I keep the arrows open. This is the master stroke that we are going to follow. If you tend to just cover it like this or draw the node, you'll mess it up badly. Okay, let's move ahead. So H depends on E and F. Same combination of E and F appears again, and E or F does not come individually. Can you see? So we don't have them coming together again. So what we'll try to do is we'll end them on the same node here, E and F, and we'll start activity H and activity I. All right, fine. Now activity J, as we see here, depends on I and G. I and G we can end at the common node. Here it is, and we can start activity J. Similarly, K depends on activity H. So H, as it ends, we can start activity K. Now after all the activities are done, we will see how many open activities are there and we'll converge them to a finishing node. So as we can see, J and K both are open, so let us converge them to a single node here. Now our network is ready. Now let us start numbering. Again we will do the same process. Initial event will be coined as 1, and then we will delete all the outgoing arrows. So we have now 2 more initial event, this and this. Let us name them 2 and 3. Again we will delete all the outgoing arrows from 2 first, so this will be 4, and then we'll delete all the outgoing arrows from 3 and 4. Okay, so when we delete with 3, we can see that still incoming arrows are there, so we have to delete it from 4 also. So this will be the initial event, so we'll number it 5. Similarly, we'll delete all the outgoing arrows from 5. We have another 2 initial events, which is 6 and 7, and the final event is 8. So this is how we are going to construct the network. Now following these rules properly, you can construct any network diagram that is given in your book. And if you don't trust me, just give it a try. Just give it a try. You will never be wrong. I can guarantee you this. Now to understand more about this subject, about CPM PERT, or about any other thing related to operations research, you can comment and tell us. And if you want to go in-depth knowledge, go for the in-depth knowledge about operations research, please do join the application. Please see the content. If you find it useful, you can purchase the course then. So I hope this video was very useful for you, and please comment us what else you want me to share with you about operations research, and we'll come live again. We'll help you with this. So I hope we are done with it, done for the day. Thank you very much for joining.